Good morning, ladies and gentlemen. Are you fine? Everybody is fine. In this video, I will show my new book entitled Self-Consistent Fields in Atoms, Hartree and Thomas-Fermi Atoms by N.H.March, Department of Physics, Imperial College of Science and Technology, London, SW7. Pergament International Library of Science, Technology, Engineering and Social Studies is very interesting book in atomic physics. This monography contains outline and two parts. Part 1 content chapter 1 entitled Central Field Wave Function and Angular Momentum Operators. Chapter 2 Concepts of Self-Consistent Field. Chapter 3 Thomas-Fermi Atom. Chapter 4 Energies of Atoms and Ions. Chapter 7 Atomic Order Properties. Chapter 6 X-ray scattering and electron densities in atoms. Chapter 7 Electron exchange and Slater determinants. Chapter 8 Electron-electron correlation. Relativistic effects in heavy atoms is chapter 9. In plus appendices entitled 1. Orthogonality of solution of Schrödinger equation. 2. Radial wave function for hydrogen atom. Variation methods. Hartree equations derived from a variational principle. Solutions of the dimensionless Thomas-Fermi equation. Hamiltonian for charged particle in an electromagnetic fields. Momentum wave function in atoms and wave equation in momentum space. Morse, Young and Horwitz wave function for heavier atoms. X-ray scattering from gas and non-spherical molecules. Self-consistent field of hydrogen of dihydrogen molecule. Relation between charge density and its gradient at nucleus. Solution of Dirac equation for hydrogen atoms. The part 2 is content by 4 chapters or for monography or for original publication. The first publication is entitled The Wave Mechanics of an Atom with of no Coulomb Central Field by D.Hartree. The second publication is The Calculation of Atomic Fields by Thomas. And the very original publication, A Statistical Method for the Determination of some Atomic Properties and the Application of this method to the theory of the periodic system of elements, is writing by Enrico Fermi, the famous physicist and Nobel Prize in Physics in 1937. The last publication is a simplification of the Hartree-Fock methods by Joseph John Christopher Slater, the famous atomist physicist and theoretical chemist. Part 1, donc, central field wave function and angular momentum operator, introduction, angular momentum and central fields, shapes of atomic wave function, dependence of wave function and phi and magnetic quantum number m, dependence of wave function and azimuthal quantum number L, eigenfunctions of L square and projection of angular momentum, and the problems. Chapter 1 contains 5 problems. Chapter 2, concepts of self-consistent field, size of atomic wave functions, wave equation for helium atom, variational calculation of ground state of helium-like system with nuclear charged seed A, best possible orbitals for helium atom, Hartree self-consistent field in heavy atoms. Chapter 3, Thomas-Fermi atom, classical energy equation for fastest electron density and maximum electronic momentum, electron density for Coulomb field, approximate self-consistent field in atoms and ions, physical interpretation of positive ion in Thomas-Fermi theory, and the 3 problems. Chapter 4, energies of atom and ions, variational derivation of Thomas-Fermi equation, evaluation of total electronic energy for heavy atoms, derivation of bending energy formula, relation between different energy terms for heavy atoms, Foldy calculation of atomic bending energies, and 4 problem, and electrostatic potential at nucleus to the electronic charge Claude, and effective total charge in Hartree theory, and 4 problems. Chapter 5, other atomic properties, internal diamagnetic field in atoms, orbital diamagnetic susceptibility, derivation of Lamb's results, quantum mechanical calculation, linear momentum distribution in atoms, calculation of R square of helium atom, mean linear momentum, orbital angular momentum, eigenvalues for potential related to Thomas-Fermi self-consistent field. It is very interesting books. Thank you for your attention. Don't forget to subscribing in our channel for more videos or more and interesting monographies. Thank you very much.